Okay, we're going to take a look at two quick problems from section 3.2, the numbers 5 and 6, very much similar. Number 5, we're going to use the power rule to compute the derivative. So notice now we're not using the limit definition of the derivative to find the derivative. We're using the shortcut rules, and we developed the power rule. And we're going to make use of that. Just to recall what the power rule here it is, the derivative with respect to x of x to the n, where n is any constant, is n times x to the n minus 1. Basically, we bring the power down in front and subtract 1 from the power, and that turns out to be the derivative. For instance, x cubed, the derivative of x cubed would be 3x squared. Now, make note of the, be careful when you're doing the achieve that they have things in parentheses are important. Use symbolic notation and fractions where needed. The way I'll say this typically on a test is give exact value. Okay, so an exact value would be like 1/3 as opposed to 0.333 or 0.33333 or whatever. Or give an exact value like 2/7, not the decimal approximation of 2/7. Okay. Now, there are some exceptions to that, like 1/2 can be written as a terminating decimal, if you will. 1/2 is just 0.5. So, I mean, in a test for me, I would take either one of those, but in Achieve, they want 1/2, the fraction, not 0.5. Okay, so let's just take a look at this real quick. The derivative with respect to t of t to the negative 3. And then, so notice the black parentheses. That's the way I'm going to do it. The book and the Achieve don't usually put it in parentheses. This is take the derivative with respect to t. This is the differential operator. So it needs to operate on something. I like to put that something in parentheses. So this is saying take the derivative with respect to t of this function of t to the negative 3rd power. Okay, so I like to put that in parentheses. You don't have to. Obviously, they don't do that in Achieve or in the book. And then there's this long bar, vertical bar, and then this down here. What's all this mean? This is the evaluation bar. When we're using the Leibniz notation for finding a derivative, as opposed to the prime notation like f prime, to evaluate the derivative, we don't have an easy way. Like f prime of x, if I want to find the value of the derivative at 2, would just be f prime of 2, right, with 2 in the parentheses. We don't have that here, so we have to have the evaluation bar. This basically means evaluated at or such that what, and here's the condition that when evaluate it when t is equal to 4. Okay, so we're going to find the derivative and then evaluate it at t equal 4. Now, so let's first find the derivative with it, and then we'll just plug in t equal 4 when we're done. So finding the derivative by the power rule says what? So negative 3 is a constant n. So we bring the negative 3 down in front, subtract 1 from negative 3, we get negative 4. So be real careful. I've seen students, do some basic arithmetic errors and say that it's actually negative 2, but it's not. Negative 3 take away 1 is negative 4. So be careful about subtracting sign numbers. And then I just want to note t to the negative 4. What's that mean? We'll recall for exponents x to the negative n is 1 over x to the n. So when I see this derivative, negative 3 t to the negative 4, that's really negative 3 times 1 over t to the positive 4. All right, or negative 3 over t to the 4th. So that's really what I want. And since they're looking for fractions, right, exact form, right, that's what we need to do. You can't leave a negative exponent in your answer. In other words, you just can't write this as negative 3. And remember, we're evaluating it at 4 to the negative 4 power and leave it at that. You have to evaluate it. Okay, so what is 4 to the negative 4 power? Well, it's 1 over 4 to the 4th. So if I plug in t equal 4 into the derivative here, which is the same as this, I just get negative 3 over 4 to the 4th power. And 4 to the 4th power is 256. So here's the exact value. So you could have a decimal equivalent for that, but this is the answer you should give, certainly in Achieve and on tests when I ask for the exact value. Okay, so there's the number 5. We'll go through number 6. It's very similar. Again, use the power rule to compute the derivative here. So again, I've put that in parentheses. So we'll do the same thing. I'll find the derivative with the power rule, right? So negative 2/5 is the constant exponent. I bring that down in front. And then I need to subtract 1 from negative 2/5. So how do I do that? Well, negative 2/5 take away 1, in order to subtract fractions, I need a common denominator. So -2/5 minus 5/5 is 1, right? And I got -2 minus 5 gives me -7/5. So that's what I have for the exponent. Now here, you could rewrite this, as we said, and I'll talk about that here, as 1 over t to the 7/5. You can write it that way. But I'm just going to note, since we're evaluating at 1, we can get away with that, because 1 to any power is 1. So this is equal to 1. And I get -2/5. That's the answer. If you're going to evaluate this at some other value than 1, I just want to make you aware of this. So what does it mean to plug into 1 over, of course, t to the -7/5 would be 1 over t to the 7/5. What does that mean? Well, 7/5 power means the 1/5 is the 5th root, and then the 7 is the 7th power. So you take the 5th root and then raise it to the 7th power. And of course, you're dividing that into 1. This expression could also be done as take the t and raise it to the 7th power first, and then take the 5th root. You can do either order. Okay. Typically, I'm going to evaluate an expression. I'm going to do this first if I indeed can take the 5th root. If that comes out to, for instance, a whole number, something that I can find. Let me give you an example. 32 to the -7/5 power then would be 1 over the 5th root of 32 to the 7th power. And the 5th root of 32 turns out to be 2. Why is that? Because if you take 2 and multiply it by itself 5 times, 2 to the 5th power, you get 32. So the 5th root of 32 is 2. And then 2 to the 7th power is 128. So this would be an exact value. So make sure that you know how to give exact values and not just the decimal equivalent. Because again, I will look for exact values on tests, and Achieve wants it as well. All right, so there's number 5 and 6. Hopefully this is helpful for you.